So this is kind of the pros and cons of this device. We get a high accuracy for measurements in both the horizontal and vertical axis. It is, as I said earlier, it's a non-contact situation with any of the radioactive components on the table. This is automated, or has the potential to be automated in the linear or in the horizontal position, and it's fully automated with the measurements that the laser is taking throughout the process. All of the materials that we used for manufacturing were made of 6061 aluminum, so very readily available here in town, and also easy to machine and weld. So that's a nice way to make this. When the laser showed up, I was so excited that we actually had something. That was our first part. And what I did is I'm outside of the Eubank gate at work where it showed, and I had it mounted on just my desk. And we had some vehicles driving by the road, and what I was watching for is I had it mounted and taking measurements off of a fixed object. So it was, everything is static. It was just sitting there taking data. And I ran that for 20 seconds or so as these vehicles would pass. And you would actually see residue of vehicles driving by. I also had it on a couple times when there were explosive tests out at Sandia, and you'd get a big pulse in there where something had happened. And the fluctuations you would get on a table, so nothing fancy as in like a isolated table, everything that would give an oscillation, it was always less than 0.1 millimeters. So that remained below that range. So yes, we did look at that. There was actually, because that was run with just a linear solver, and I actually had to go from a linear solver to a nonlinear. And what the linear solver was giving me was a damped frequency, and it was assuming that the base was an isolation point. And so once we did that test I was talking about, where we would give it that impulse and let it vibrate, that's when we discovered that data was goofy. So then we stepped up to the higher level. We went from a Cosmos solver, we went up to a Geostar nonlinear solver, and that gave us, I think it was 3.4 something, 3.45 is what I think it calculated it, and it was 3.26 from that nonlinear. So that was, yeah, that was something that we found it, but that was kind of a check for us to see, once we did get that data, that didn't actually jive with what we. I don't know that we specifically looked. Well, okay, for the horizontal motion, that's once we got to the realization that this motor, either there was a problem with the windings, or there was a problem with what we could handshake from our control board to what we had in the motor. We were almost at a standstill, like, well, oh my gosh, this product isn't going to work. And so what we actually did that we haven't discussed yet, on the back side of that, we have it's actually a metric tape is attached to that. So what we did is we forced a analog kind of output almost to the linear slide, so that as the operator's either running it by pulling the slot or pulling the boom itself, or running the hand knob on there, so we were trying to work around problems like that. Does that kind of answer?
That's a partial answer.
Okay.
Right. Our device doesn't actually do the calibration itself. We're supplying measurements to the user so that the user can then turn the knobs to perform the actual calibration. We're giving them the information that they need to perform the calibration.
What kind of information are you giving them?
We're giving them the height of each detector, and also the height of the emitter, so that they can get the height of the detector at the appropriate height relative to the Controlatron. And then we are also giving them the distance between the Controlatron and the face of the detector, so that, because this distance right here and this distance right here need to be equal.
How do you measure those?
Those are measured with the linear slide. As the laser passes over the detector, it's getting an input signal. When it falls off the face, it stops receiving an impulse signal, or a signal from the laser, At that point, we would count the number of steps that it takes in order for it to get a signal, and we would correlate that number of steps into a distance.
Question 1 is no. This has not yet been installed at Sandia or tested at Sandia. And that, I guess, would also be a task to still complete. So that almost is to the same.
Do you have any other tasks in terms of controller or tests or anything else over there you have to perform before you can hand this over to them?
As it stands, it's pretty much ready to go.
Besides the fact that it's done.
Talking with the engineers at Techno-Easel and talking with people at UNM and around the community on how that motor is supposed to work, it's unclear whether the motor is bad. It's a custom-built motor, and it's unknown whether that motor itself is faulty or if what we're doing is faulty. But that board we have running the outputs to a stepper motor, from all of our diagnosis on that, it's performing as it should. So it's kind of leading us towards the direction that the motor on that slide is faulty, in which case it very well may work with a corrected motor on them.
Well, I don't have, we don't have certifications now. For the most part, we're trusting the specifications given us by the manufacturer. So, I mean, it's from what we saw, we did a quick measurement of the 0 point, which is the 7 inches, and it was using roughly a digital caliper. We did measure 7 inches from the 0 point where it started getting a signal. So trusting that the laser is giving us data that is accurate, it's a really quick calculation, and we basically take the height of the boom and subtract the distance that the laser is giving us, and we have the height of the controller. So
right. Yeah, as well as we can tell with a mechanical way. So like Curtis was saying with that 7-inch standoff. So with a digital caliper set at 7 inches, whether or not as it's set, wherever 7 inches may fall here or so, whether that laser is outputting 12.2 or 7.001. Right. Well, almost back to that question about trucks driving by or different responses. Looking at the statistical data from something that's not moving with the laser, we were getting an average of 0.002 millimeter fluctuation. That's where if nothing was moving and we didn't have any big pulses causing changes, we were getting 0.002 was the average value, and then the deviation of that was 0.001.
I know there's other questions out there, but we're going to move on to the next team. So let's thank this team here. So.